Let's have a look at the Show What You Know questions for average atomic mass. You should have already attempted these problems and be checking your answers now. Let's go ahead and look at an example. What is the average atomic mass of silicon based on the data table showing its naturally occurring isotopes? Now, notice how silicon has three different isotopes, silicon 28, 29, and 30. That means we're going to have to do mass times percent abundance 3 different times. Let's do 28 times 92.23, 29 times 4.68, and 30 times 3.09. We add all of these up, and then we divide by 100 since that's the maximum percent, and we get an average mass of 28.1226. Notice how each isotope has a whole number mass, but the average mass is a decimal. Let's go ahead and try another example. What is the average atomic mass of argon based on the data table showing its naturally occurring isotopes? Now, once again, we have 3 different isotopes. We have argon 36, 38, and 40. Make sure each isotope is paired up with the correct percent abundance. So we have 36 times 0.34, we have 38 times 0.06, and we have 40 times 99.60. We can add all of these up to get the total atomic mass, divide by 100 to get the average, and we have 39.9852. Let's look at another example. The average atomic mass of chlorine is 35.45. Which isotope is the most abundant, Cl35 or 37, and how do you know? Well, notice how the average is closer to 35 than 37. That means that you'll have more Cl35 isotopes than Cl37, and Cl35 is the more abundant. Now for example 4, what would chlorine's average atomic mass be if both isotopes represented 50% of the chlorine population? Well, if each isotope were represented equally, that would mean that the average would be calculated as a standard average. This would come out to 36. So it would be 35 plus 37 divided by 2 would give you 36 AMU. Let's consider example 5. An element has 3 isotopes with the following mass numbers, 39, 40, and 41. The average atomic mass is 39.10 AMU. Which isotope is the most abundant, and how do you know? Well, notice how 39.10 rounds to 39. It is the closest to isotope 39 because that mass number is the closest to the weighted average. That means that isotope 39 is in control of the average. Let's look at example 6. An element has 3 isotopes, A, J, and M. If their respective abundances are 12, 73, and 15%, what will the average mass be closest to? Well, notice how J has the largest portion of the isotopes. That means that the average mass will be closest to that of isotope J. Now let's look at example 7. How will the second most abundant isotope influence the mass? Well, isotope M will be able to pull the average towards its mass, but not as much as isotope J can. It will, however, have more influence than isotope A, the least abundant.